And now you will hear me presenting the speech I did on behalf of UNFCCC at the Climate Week in Addis Abeba, where circularity was discussed, how circularity can contribute in that we fulfills the ambitions set in the Paris Agreement. You will see 5 different circular solutions, all of them possible to scale, and all of them will both mitigate the climate challenge, but also be able to be financed by the raw material that we produce if we have the right conditions. The speech as such will be able to download from UNFCCC's homepage with also my thank you letter for the co-conveners, for the 2 leaders of this discussion, the 2 chairmen. And so this is from UNFCCC's work. And UNFCCC are that UN organization that also are carrying the climate negotiations. So they are the ones that are doing the COP discussions. So this was the last climate conference before the final negotiation this year for the COP30. So of course I started with the background, the history of what Ragn-Sells come from. And we have done 3 transformations, from a transport company to a waste management company to now become a recycler in today's linear economy. What's happening now is that we are moving into the next step, becoming a raw material supplier and a detoxifier in the future urban flows, where circular economy is the future. So what we did in 2015, or to be honest in 2016, we presented these principles. And these principles has guided us to understand what to invest in, what to de-invest in, but also what to put into research. And one of the examples is what we have seen here today, the collaboration with Vilocan, meaning that the solution de facto reduced the need of virgin resources somewhere else. It decontaminates, remove the risk for contamination, and thirdly, it doesn't put any hindrances to future generations. It could be both social and environmental. And if you can say yes to those 3, then we will invest. We also have committed ourselves to become net zero by 2040. When we did the analysis, we discovered that to become net zero is nothing compared to what we can contribute with, especially when we talk about scaling circular solutions. So we are using the Exponential Roadmap Initiatives framework. Science-based targets are our model, how we use, meaning that we make sure that everything we do are based on science-based targets. But we focus primarily, to be honest, on different circular solutions, that all of them are possible to scale globally. One of the things that we have done is to try to understand how will future material flows look like, and we especially target the wastewater. And I stated it earlier today that today's obligation for municipality wastewater treatment plants is to do bad things less bad. Here we see a huge potential because that's the largest untapped resources of fresh water. Yes, it's contaminated today, but then how can we make sure we can recover the resources and remove the contaminants? We used also the planetary boundaries as a guiding tool for us to how we should invent innovations. And I remember the call I had from Jan Svärd, the CEO of VC Mining. He said, well, we might have a solution for collecting ammonia, nitrogen, in the wastewater. Is that good or bad? Yes, that's the one that has the biggest threat when it comes to the planetary boundaries. That's the one that are out of scope. If you can solve that one, we probably have a support for this one. So that was the way how we also said that this is important to go forward with. The second example was the dialogue we had with Chromafora, that is partly owned by us, that had a solution for recovery of heavy metals. But the problem with that was that the big companies that are using heavy metals are just used to their traditional technology. I shouldn't name any companies. But I asked them, do you have anything when it comes to organic chemicals? Yes, we have tried PFAS. This was in 2018. Now they have a solution to collect PFAS that are probably world leading, still under development. But these innovations in combination with our phosphorus innovation can really create this potential for wastewater treatment plants. So even if we for long had advocated for the mind shift change and have policies in place, we also added this with different innovations that also will bring this to life. I will come back to that. Yes, we are focusing on different material streams. Solvents are one thing. And the magic with that one is everybody uses solvents sometimes, especially the industry uses solvents that we have discussed. The interesting part is that the savings, the LCA analysis when it comes to the climate dimension, only the climate, is a reduction of 90%. We are part of the Exponential Roadmap Initiative. It also means that we have the potential to also certify our processes towards UN Race to Zero's program. And it means that we are now in the final phase of certifying this as a climate solution. That means that the reduction is more than 50% compared to virgin, the traditional way of handling of the materials. And this will be the first process out. Hopefully, we can have more climate solutions going on that can guarantee the CO2 saving. A next example I also showcased in Addis Abeba online was the innovation where we are using carbon dioxide to produce new raw materials. When it comes to the solvents, the challenge has been for many years when it comes to the quality. Is it good enough? As good enough as virgin? Here we have another problem. The problem is that the legislation in Europe doesn't allow or doesn't promote the use of carbon dioxide to produce new raw materials. So what we do is that we take calcium oxide, combine it with carbon dioxide, and it becomes limestone. So we don't need to dig up limestone in that extent that we do today by adding on this factor. So we have a positive impact when it comes to water, huge positive impact when it comes to climate, of course, but we're not allowed to do it. So again, we need to do the same thing as we heard here from Peter Wall. We need to convince the EU to change the direction. Of course, the two main innovations that we are now focusing on internationally are our solution for recovery of nitrogen or ammonia from wastewater, and the second one for phosphorus. And I'll start with the first one when it comes to nitrogen. What we do is that we take the nitrogen in the reject water step, where we have a high concentration of nitrogen. And it's just after the biogas production. So if a plant has a biogas production, they also have a reject water, where the water goes back into the main water stream. Here we are very fortunate now, finally, that the legislation reduces the amount of nitrogen that are allowed to be let out. So they need to reduce that amount. But also that EU has put a demand that we need to produce more energy. Each and every wastewater treatment plant needs to be energy neutral. And with our technology, the wastewater treatment plant can maximize the biogas production. What happens when they maximize the biogas production is that you have more ammonia going back into the mainstream. But we take more than 95% of that. So it means that there is no problem. And we do that with a much lower capex, the traditional way of removal of nitrogen. So instead of 1 billion or 2 billion investments, that might be only 100 million in investment. And at the same time, we are producing a nitrogen fertilizer. So the wastewater treatment plant can also start selling the fertilizer. Here we have one of the other problems. Wastewater treatment plants is just a cost dimension today. They're not used to generate incomes, but this of course must change. The second one, the phosphorus, we know that the resources are scarce, and we heard about River Wye before, both that we have ammonia leakage or nitrogen leakage into the water, but also that we leakage of phosphorus. What we are doing is that we are producing a process that not only separates the high quality phosphorus, but all elements in the sewage sludge will be brought back. The iron chloride, the aluminum sulfate, or the silica. But of course, the most valuable resources, the most highest price resources are the phosphorus. And the end product is so pure that it's perfectly fitted for feed phosphate. What will happen when we can sell it as a feed phosphate in Europe is that the income from the process will lead to that the wastewater treatment plant's cost to treat sewage sludge has potential to go from a cost to an income. These are one of the biggest costs for the wastewater or for the water facilities in the city. There's another source of phosphorus also, and here we have our solution to collect fish sludge or fish poo. And we already have this up and running, meaning that we are collecting fish sludge from fish farming. We transport it already now to biogas. What we do now is that we are making it able to be scaled globally, but also to close the loop perfectly. It means that also that the phosphorus and the nitrogen that today are just being wasted in the process are now also being recovered. And this is a collaboration between 6 countries. It's our technology that are being used, and it is the Hardanger Bay, Hardangerfjorden in Norway that are the test area, together with the Baltic Sea, because the island of Åland is also part of the project. And in 2029 we will have the results, and we will be able to share them. And one of the things, most important things, is of course the end product phosphorus, because at exactly the same thing, if we compare the wastewater treatment plants and the high value, the amount of phosphorus in fish sludge is 16% if you incinerate it. The amount of phosphorus in sewage sludge is 9%. And the amount of phosphorus in the mine in Siilinjärvi, the only mine in Europe, of 1.7%. And the high value of phosphorus, so you understand, so then suddenly the cost to remove the phosphorus will be paid by the outcome if we can sell it as a feed ingredient. And this will also have to understand, because this is one of the big challenges when it comes to fish farming, when the phosphorus and nitrogen enters into the fjord, the fjord dies, or it takes a couple of years to restore it. But by doing this, you can also increase the fish production with a lower environmental impact. We have the flag of Canada there, because the Canada doesn't have the same legislation in Europe as Europe. So now we will start selling the phosphorus to Canada. We have now finalized the application, so we're now handing in the application to also be able to sell the phosphorus from our 2 first factories, now being set up, one in Germany and one in Sweden. And by doing that, we of course will have the pressure of to pressure EU. So my question I always ask when I meet politicians there is, where do you want our next 50 plants to be built? In Europe or outside of Europe? You decide. And when it comes to Canada, we have in this case a partner. We already have a customer that want to create the market in North America, and he's based in Vancouver. And I will meet him again together with federals and ministers in November when we take the next step in our dialogue. So this is happening, and we can do that without subsidies in the end if we have the right to sell the phosphorus. Yes, we have used the planetary boundaries as a guiding tool. We started with that in 2015 already, to have it as a little bit of a reminder what is possible. Both when it comes to novel entities, we decided that detoxification will be a key component for us. Last year, that was a theme of the Framtidsdagen, where we also talked about the important role of landfills in the future. Not to dump things, but to make sure that we doesn't pollute the environment. So it has a very critical role. But also, as I told you, we need to have a solution on PFAS. And if we can have that solution, there is a huge market. And that was also created huge interest when I was in Monaco this June, invited to present, especially the PFAS innovation, for the Investors Collective. And so the dialogues are ongoing. The challenge, though, is still, everybody knows it's a headache, but there's no real pressure of doing things. But here we see a difference now with nitrogen, and especially with phosphorus. What we have done is that we have deep dive into the different planetary boundaries. So I will now show you for the first time the impact, the positive impact with our circular solutions when it comes to different circular solutions. But first, this is a new update. Peter talked about what happened for 3 weeks ago, I think it was, when Potsdam Institute for Climate Change in Germany announced the planetary health check. What is the status? And that's where they announced that, in this case now, the acidification of the oceans are now have gone over the border when it comes to planetary boundaries, have breached the border. But what's happened last Friday is that I have now also deep dive into the consequence of the food system and how impact it has for the planetary boundaries. I will not use this picture going forward. I will go back to the old picture. This is one a little bit more complicated, but this is very important. And we, Ragn-Sells, are really a part of the food system, both when it comes to nitrogen, phosphorus, but also fish sludge, but also PFAS. Because if we can't remove PFAS, we can't use the food. So we have now grouped a couple of innovations. And if we see now the impact, if we implement all of them, scale them globally, they will have a direct effect of these different boundaries. And of course, the phosphorus are the one that has the biggest impact, positive impact. But let's first start with that one. So by adding on this, each and every big city in the world would implement phosphorus recovery, where they maximize the phosphorus input. We see directly that 4 of those planetary boundaries will be positively affected. We saw from Peter's presentation that there was a water stress. All the water stress areas he mentioned was where we have high concentration of population, the big cities. So for all big cities around the world, this will be a very low-hanging fruit. And if they can sell it as a feed, it will not cost them anything. So you understand, why don't do it? The second one, the nitrogen, are critical in many ways. Producing nitrogen fertilizer today uses 2% of the world's energy and directly have 1% of the CO2 impact in the world. Now we can recirculate it. So it's almost no CO2 impact when we produce it from the water, but have a huge potential for reduction of CO2 emissions, not only for the production. By doing that, we can eliminate the risk that wastewater treatment plants emits nitrous oxide emissions. When it comes to CO2 impact, climate, we have CO2, we have methane, and in third place we have nitrous oxide. Nitrous oxide has not been addressed at all, I would say. And that's one that we see now is coming and booming. When we have the aquaponics, we have almost the same scope as we talk about the phosphorus topic. So then they are of course interlinked because we use the phosphorus innovation in that also. But we have a direct positive effect in this case when we can remove it directly from the water. When it comes to Villucan, we see definitely that has a huge positive impact of the climate, but also when it comes to the novel entities. I would say that if you take a more even bigger system perspective, we have a huge positive impact also for the water, especially if we can reuse the water. I will not go through each and every of them, so I will stop there. But my main message, and that was also addressed in my speech in Addis Abeba, was that we need to use innovations, and we need to make sure that innovations are able to be used. Therefore, we need to have policymakers that also addresses this topic and trust in business that we like to do good. I am heavily engaged in the international dimension because we have seen that the circular solutions can contribute. And we are now happy to say that also we see that the world is listening and things are happening. After my speech, it was confirmed that UNFCCC are now trying to include circularity in the main negotiation protocol at COP30. And that will, of course, also be a big breakthrough for implementing it in the countries across the world. So I'm really hopeful, but again, to be allowed to sell phosphorus as a feed will take until 2030, I believe, before EU gives up. But we will persist and we'll create more friends on the way. And you are some of our friends that can support us going forward. So thank you so much.